Welcome! I am Teacher M. This tutorial video is focused on how to use sum and difference rule to find the derivative of a function. If you're interested, stay and watch the entire video. This video will discuss sum and difference rule of differentiation. Before you continue watching this video, I highly recommend to you to watch constant rule, power rule, and constant multiple rule of differentiation. You may watch it using the link on the description below. Sum and difference rule of differentiation simply means that if you have more than one function combined with either addition or subtraction, you can take the derivative of each function before adding or subtracting it. For example, what's the derivative of x squared plus 4? Take the derivative. Based on this rule, we can take the derivative of each terms of the function, and it is equal to the derivative of first term plus the derivative of the second term. This is what we mean by the sum and difference rule of differentiation. To take the derivative of each term, we will use other rules of differentiation which are discussed on the previous video series of differentiation rules. In first term, apply power rule. Its derivative is 2 times x raised by 2 minus 1 plus apply constant rule in second term. The derivative of the second term is 0. Simplify power. The difference is 1. Simplify it further. Then, the derivative of x squared plus 4 is 2x. Another example. What's the derivative of g of x is equal to negative 2x cubed plus x squared minus 3? Take the derivative of the function. Similar to the previous example, by applying the sum and difference rule of differentiation, we can take the derivative of each term of the function. And it is equal to the derivative of the first term plus the derivative of the second term minus the derivative of the third term. Again, this is the only part of the solution that we use sum and difference rule. To take the derivative of each term, other rules will be applied. To get the derivative of the first term, apply constant rule multiple, which allows us to pull out the numerical coefficient of the term and take the derivative of x cubed. On the same term, apply power rule, and it is equal to negative 2 times the derivative of x cubed, which is 3 times x raised by 3 minus 1 plus apply similar rule on the second term. The derivative of x squared is 2 times x raised by 2 minus 1 minus the derivative of the third term, which is 0 by constant rule. Simplify power. The difference of 3 and 1 is 2, and the difference of 2 and 1 is 1. Simplify it further. The product of negative 2 and 3x squared is negative 6x squared plus 2x. The derivative of the function is negative 6x squared plus 2x. Next example, find the derivative of y is equal to 2 over x squared plus 5x. In this example, before taking the derivative, we can rewrite first term. Using exponent rule, 2 over x squared can be written to 2x raised by negative 2. We can now take the derivative. Apply sum and difference rule. It is equal to the derivative of the first term plus the derivative of the second term. Next, apply constant multiple rule to the first term and to the second term. To get the derivative, apply power rule to both terms. It is equal to 2 times the derivative of x raised to negative 2, which is negative 2, times x raised by negative 2 minus 1, plus 5 times the derivative of x, which is 1, times x raised by 1 minus 1. Simplify powers. The difference of negative 2 and 1 is negative 3. And the difference of 1 and 1 is 0. Simplify each term. The product of 2 and negative 2x raised to negative 3 is negative 4x raised by negative 3. Plus, the product of 5, 1, and x raised to 0, which is 1, is 5. Rewrite first term using rule of exponent. And it is equal to negative 4 over x cubed. Thus, the derivative of the function is negative 4 over x cubed plus 5. Last example. What is the derivative of h of x is equal to 2 square root of x minus 3 over cube root of x. In this example, we can rewrite radical term to a term with a fractional exponent. Square root of x can be written as x raised by 1/2. And cube root of x can be written as x raised by 1/3. Similar to the previous example, 3 over x raised by 1/3 can be written to 3x raised by negative 1/3. We can now take the derivative of the function. Take the derivative of the first term and the derivative of the second term using sum and difference rule. Then, apply constant multiple rule in first term and in the second term. Apply power rule to each term, and it is equal to 2 times the derivative of x raised by 1/2, which is 1/2, times x raised by 1/2 minus 1, minus 3 times the derivative of x raised by negative 1/3, which is negative 1/3, times x raised by negative 1/3 minus 1. Simplify powers. Difference of 1/2 and 1 is negative 1/2. And the difference of negative 1/3 and 1 is negative 4/3. Simplify each term. The product of 2 and 1/2 is 1. Multiply 2x raised by negative 1/2 is x raised by negative 1/2. And the product of negative 3 and negative 1/3, which is positive 1, multiply 2x raised by negative 1/3, which is positive x raised by negative 4/3. Rewrite each term using exponent rule. X raised by negative 1 half can be written as 1 over x raised by 1 half. And x raised by negative 4 third can be written as 1 over x raised by 4 third. Rewrite each denominator into radical expression. X raised by 1 half is equal to square root of x, and x raised by 4 third is equal to cube root of x raised by 4. Simplify cube root of x raised to 4, and it is equal to x times cube root of x. This is now the derivative of the function. There you have it. How to use sum and difference rule of differentiation in finding the derivative of function. Other videos will discuss remaining basic rules of differentiation. If you learned on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!